overarching theme for Future Lab is technology for a better world. So when I'm talking to companies around the world, looking for those brilliant stories to tell in Future Lab, what I'm also looking for alongside incredible technology is the stories of where technology is genuinely changing the world or will be changing the world. And then we talk about, how technology is a force for good, how science, artificial intelligence, robotics, how these are not necessarily intimidating stories. They're not necessarily a threat. They are, they're collaborative tools. They are positive forces for good to help us create a better world. To understand the oceans better, to understand how we can feed 9 billion people by 2050. All these incredible challenges that we're faced. And technology can really be the tools or the toolkit that can help us to make that change. So in terms of curating Future Lab, obviously I'm wanting to tell stories of really pioneering technology and science, and they can be very complex topics, really brilliant minds behind these innovations. But we need to tell those in ways that make them accessible. The most complicated examples of artificial intelligence, we need to tell those stories in a way that people can really get on board with how artificial intelligence is being integrated gradually into daily life, how it's a benefit, how it's a force for good. So it comes down to the way that we stage those stories, the interactive pieces that we bring in. So as soon as you get hands-on with something, it becomes more engaging, it becomes less scary, even if it's a very complicated piece of tech. So wherever possible, I'm trying to stage this in a way that people can actually touch the future, because then it's not as scary as you might think. But we do see that with younger audiences, there's less fear around these new concepts, that some of the youngest kids coming through are the ones who are totally comfortable engaging with the robots, and it's like robotic dog wandering around, autonomous dog wandering around. Babies are just like, this is great, this is my future, and they're really comfortable with it because they have no fear. So the STEM education part is really, it's really important as well, because they're the future astronauts, the future engineers, the future racing drivers and ocean explorers. And yeah, they have no fear. They really embrace it, and then they bring their families along for the ride.
And our main goal is effectively to transform operations at sea, allowing the people and planet to thrive. So we have a strong environmental and sustainability drive, but also to just change the face of how we do shipping around the world. In the interim, started with lean crew and effectively transformed the shipping to robotic and hopefully eventually autonomous.
At some point, and with the relevant sign-off from the regulatory boards or us proving that it's safe to operate, you'll get to the point where we can be in a fully automated way, or remotely operated is almost where we're trying to sort of bridge that gap in terms of having things connected via some form of global network, where we can then say, well, we'll operate it as we're doing from our remote control centre down in Southampton. So there's a level of autonomy. It's not going to think for itself straight from the bat. It's going to be sort of remotely operated and then driving down to the point where we're more autonomous or autonomy assisted in terms of being remote controlled or remotely operated. So I think it's really back to what we're trying to achieve, and it's not because we want to be the first AI or autonomous sort of shipping company or marine company. It's the fact that we actively want to be able to do things in a different way, to think in a different way, to be green in what we do, and to really reduce everything, in terms of carbon emissions or carbon footprint from what we're doing. So if that is having less people on a vessel to operate something that is a conventional vessel that puts out a ton of CO2, we want to do things differently. And so it's not a drive for sheer autonomy or sheer AI enablement. It's a drive for a different way of doing business.
So this is one of the Saab Sabertooth. This is one of two that we used on the endurance search. It's a remotely operated vehicle, and it can be deployed from any of our chartered fleet, and eventually it will be deployed from our armada fleet. Yes, so we were involved in the discovery of the Endurance, the Shackleton ship. So we had an ROV project team offshore flying the ROVs and assisting with the search alongside the Falklands Maritime Heritage Trust.
So we'll have our first 78-metre vessel, which will have a level of robotics and remote options fitted, and a full sort of geotechnical multi-role payload fitted by about sort of May time next year. and then they come thick and fast after that. So we're really looking at starting, from about May, on a drumbeat of about every month after that, putting vessels afloat and doing it in a way. I think what that launches into is a series of conversations, almost with the Maritime and Coastal Organisation, in terms of what safe manning of these vessels looks like, and how we can then start to reduce or replace live bodies on board vessels and put them in our remote control centre down in Southampton, so that we do it in a different way. So starting from May next year, really is what we're aiming for. So the first ones we'll have rolling off will be a hybrid drive, so between diesel and electric. In terms of the thing that we're doing is, in terms of the capability fitted to that vessel, the vessel is so much smaller than a conventional alternative. So we're already sort of being greener by the fact that it's a smaller boat. From there, we're looking at sort of green ammonia and other ways, and we're fitted for, but not with, that sort of capability as we continue to expand on it. So very much the focus for our team is get it green, get it small, get it at some level of remote controlness that we can do it in a different way. And that's really driving the entire business forward.
On the European Service Module project, which is part of the larger NASA Artemis Program. So basically what we're doing here in Europe is we're providing a service module, so one specific module of the spacecraft that'll propel astronauts towards the moon again. So it's the first time we've been back to the moon in over 50 years, and this time Europe is part of it with this European Service Module. It's a really exciting project to be part of.
So we want to make it cost effective, we want to make it something which delivers real benefits for society. So those could be scientific benefits, they can be new knowledge, new understandings, but also new technologies and new ways of doing things that we can translate into changing and helping to do things on Earth in a more sustainable way too.
So the European Service Module contains everything that we need to keep those astronauts alive on their journey to the moon and of course back again. So we've got oxygen tanks, we've got nitrogen tanks, we've got water tanks, we've got thermal control systems, we've got big solar arrays so that we can generate power for the spacecraft, and most importantly we've got a really big propulsion system with a big engine that's going to be the engine that's used to propel us to the moon. So it really is, in my opinion, the most important part of this whole spacecraft, and the astronauts can't get there without us.
One thing will be really important to learn to do is to understand what the environment is that crews will encounter. So we're looking there particularly at the radiation environment, which is very different from what you would see on Earth, and trying to understand what that would look like inside the capsule. What's the radiation that they would experience? So we have European radiation instruments which will be on these early flights, looking at measuring that radiation environment so that we can better understand the risks that astronauts will encounter, and also how we can best mitigate those risks for the future. So in the very early missions we'll be looking at this. When we get to Gateway, we're looking at understanding that environment again in a more comprehensive way. We're looking at, again, understanding what the impacts of that are on human physiology, on the biology that we carry with us. Learning what that environment is like in terms of the fundamental physics of how the moon and the Earth and the magnetosphere from the sun, those things all interact together. So we're looking at that integrated thing. And then down on the surface, when we get there, it gets really exciting. So the moon is a repository of billions of years of solar system history, things that have been lost from our terrestrial geology. There are things you can find out there that you can't learn anywhere else in the solar system. And so we're really looking forward to getting access to the surface, something that we really haven't explored yet, and doing things that are really completely new.
Yes, so obviously technology's moved on a lot in 50 years or so. We've got the software capabilities have obviously improved hugely. We can take a lot more complex machinery with a lot less mass this time into space. So really every single system of this spacecraft is new and upgraded and better than it was for the Apollo missions. So in 50 years you can achieve a lot, and so this really is the new generation of lunar space travel.
So I think the internationalness of what we're doing is wonderful. So the European Space Agency has international cooperation at its heart. That's what we're about. So we have 22 countries working together with different governments, different policies, different cultures, and different languages, all working together to do things. And that in itself, I think, is very, very special. And so we're bringing together the expertise, the resources, the capabilities, the technologies of all these different international partners in a collaborative and synergistic way to accomplish things that none of us could do on our own. And I think that gives me hope for humanity, honestly. I think it's something remarkable that we're doing, and we're learning in doing this how to do extraordinary things together. And I think that's something that we can learn here on Earth too. So I think it's a hugely positive thing that we're doing for all of humanity.
So the Artemis program is a little bit different to the Apollo program 50 or so years ago. This time we're going back for longer at a time, rather than just spending days on the lunar surface. This time we're going for perhaps weeks at a time. And the idea is very much to build up more of a sustainable human presence on the lunar surface. So we're going to start to build up habitats or places that humans can use to help them survive. Also thinking about what can we create on the moon, either from the moon's resources or perhaps, 3D printing something on the moon's surface. Anything that can help us to bring that infrastructure to the moon, because anything we can do on the moon reduces what we need to do back on Earth if we want to go places like Mars. So this really is being done very much with further goals of Mars in mind. We're sort of developing technologies, we're proving technologies with that in mind. We want to prove that we can live on other planetary bodies. So Artemis 1 is actually on the launch pad right now. We've just finished the wet dress rehearsal number 4, and NASA are now pretty confident that everything's well practiced and everything's working well, and we're hoping to launch in a few months' time. So the exact launch date will be announced pretty soon.
So this first mission that we'll be seeing sort of during this year will put the Orion capsule in an uncrewed format around the moon as a test flight, and they'll be looking in later missions to go with Orion to the Gateway. And so the Gateway is an orbital outpost, a human-tended outpost that we're preparing that will be around the moon. Artemis will involve the SLS launching Orion to go to the Gateway. The crew will then go from the Orion into the Gateway, where they'll be living and working, and then some of the crew will go down to the lunar surface on a lander, then come back to the Gateway again. So that the Gateway becomes a staging post to get to the surface of the moon and back. It's also somewhere where we can have humans working, doing science and research in a deep space environment, the like of which we've never had access to before, and that will help us to learn how to, what it means to have humans living and working in this deep space place, somewhere that we will need to learn to live and work to send future missions to Mars too. So it's an integrated plan, going to the moon, learning to live and work there, and preparing to go to Mars later.
The second one, we're talking probably 18 months, 24 months after that one, and that will be the first time that we fly a crew of 4 people to the moon and back again. And then the third one, targeted for 2025, that's when we'll see the first woman on the moon. We'll see boots on the moon again in 2025, and that's really the goal, what everybody's waiting for.
Getting to Mars is going to be a really big challenge. So you're going to take humans, you're going to put them into a confined space, you're going to put them in a deep space environment, and you're going to keep them there for a very long time. You then have to get them down to the surface of Mars. They then have to stay there for a sustained period, living and working, surviving and thriving. We then need to get them back up again and then get them back. So this is a very long mission in a very challenging environment, and something that humans have never done before. No human's ever been that far away from Earth before, so we need to understand what the physiology of doing that means. We need to understand the psychology of that, and we need to understand how we're going to work and live in those environments. And so on these early missions, we'll be looking at what this means for crew. We'll be looking then on the surface of the moon at how what it means to live and work off-world. How do you survive in these environments? How do you work with the kind of longer operations cycles in a way that's very different from what we would do on the ISS? We'll be looking at how we use local resources. How do we use the things that we find in these locations to meet our needs, whether that's for propellant or for fuel, for life support consumables, for food. What is it? How do we use things in an effective way? We need to learn how to be more efficient. We need to learn how to be more effective. And we need to do that in a way that we've never had to do before. And so these early missions to the moon really prepare us for being able to go to Mars and do things there too.
I was always passionate about space because it is something that appeals to all people on Earth in the same way. It's kind of like a common denominator of all cultures in all times. Really, it's about bringing people together, and space has this unique power of really bringing communities together. And I studied lots of course, I'm an aerospace engineer by profession. I studied lots of the technical aspects. Then after graduating, I studied the non-technical aspects, the economic aspects, the political aspects behind creating space missions, organizing them, building them. And I realized that at some point, the real bottleneck for pushing space exploration forward is not much that of it's not technological, it's not scientific, but it's more in the decision-making process. It's more in convincing leadership that of the usefulness and the importance of all of this. So really, the key is education to move things forward. And Duckytown is an educational project, and it's the Duckies represent an attempt to break the preconceptions on what robotics is, and so to appeal to a much broader audience, not those demographics that would be typically already interested in robotics, who like things like power or speed or precision, or these dangerous big robotic maybe arms that you can imagine in auto manufacturing industries. Duckytown was by design built to be pretty much the opposite: imprecise, not powerful, definitely not dangerous, and the Duckies make it borderline silly. But this is because we now can appeal to a much broader demographics, a much broader audience, and show that, well, these robots that are so silly and precise and slow are actually as complicated, if not more, than the big nasty ones that are in the auto manufacturing industries. And by attracting the attention of people, all of a sudden we can introduce them to this beautiful adventure of giving life to machines, which we believe is something that is going to serve society a lot in the short and long term. When I say autonomy, I mean modern robotics, all that science and technology that goes into making robots take out decisions on the fly autonomously when operating in a real-world environment and having to accomplish non-trivial tasks. Of course, Duckytown is a simplified environment. It's not as complex as the real world, but it is crafted in such a way that it sits halfway in between the simulation environment, where typically everything ends up working because simulations are doomed to succeed, and the real world, which has, of course, complexities that are not only related to the science and technologies, but to, let's say, other factors such as politics and let's say ethical problems related to testing fleets of self-driving cars in cities where other people are going around. So Duckytown is an experimental simulator that is perfect for learning, and it's perfect for doing research as well. The Duckies represent the passengers, the citizens of Duckytown that take these robotic taxis to go places. And the Ducky bots, which are these these model self-driving cars that we showcase here today, are fully autonomous machines. They are designed to be minimal autonomy platforms. That means the simplest possible, the most affordable possible platform that is still complicated enough to do serious science, to write papers, to really explore what the real world challenges are for these technologies. They look fun, they look silly maybe, but it's a way to attract attention, not a way to trivialize or simplify what the content and the challenges of the deployment of these technologies actually are. The Ducky bots are able to take decisions on the fly in order to steer their wheels to maintain their positions in the road. And this is going on continuously. It's a completely decentralized platform. This means that each robot is collecting the data, it's processing it, transforming it into actionable information. It's using it to take decisions on its own. This means that Duckytown is a scalable platform in the sense that we can have a very small city with maybe one robot that could be operated in someone's living room or in let's say, in a domestic environment, as well as big as one can go and have as many robots as one wants to put in them and simulate way more complex interactions between vehicles and with the city itself. So we actually used Raspberry Pis themselves in the first editions of our robots. And I would totally agree that DuckyTown is a platform in the sense that more than providing a solution, DuckyTowns provides an environment and the tools and the problems, the definition of the problems, of course, and some baseline approaches to solving these problems so that we can have a billion flowers bloom. We can let people understand step by step in full transparency without hiding anything what is going on, but then starting to modify these components of, let's say, of the logic that allows these robots to be purely autonomous. So, of course, DuckyTown is an educational platform, so our objective is not performance, driving as fast as we can, but it's more to explore in a very rigorous and systematic way what are the pros and cons of different approaches with respect to the specific challenges, the specific tasks that we are asking our fleets of Ducky bots to accomplish. So, for example, we can go anywhere from implementing the so-called traditional control of traditional robotics approaches, so the perception, planning and control, or the seeing, thinking and acting, which is classic of let's say how things were done up to a few years ago until AI and particularly machine learning started to become prevalent in solving some very complex problems. But these novel approaches based on machine learning can very well be used as well to achieve to solve the same tasks. And by swapping only a bit and a piece at a time, it is very easy to evaluate what are the contributions or the pros and cons of using different approaches.
So you'll see here on every fingertip we have haptic sensors with 9 sensor points and a pulse oximetry, and so we can provide the haptic sensations, tactile sensations on the top of the fingertip for every user, and we just attach it like that. So we make deep tech smart wearable devices. So we have 2 key products. One is a Teslasuit, it's a full body haptic suit. Another one is Tesla Glove. So full body haptic suit has a free technologies that work in combination with each other but also separate.
Right.
It's tactile sensations like haptic, we call it, motion capture and biometry. So you can combine those in any shape or form and use them in different settings. So give you an example like training, we use our suits a lot for training. And so for example, if you want to learn how to play a golf, you can have a visual representation of like a golden standard that you have to follow to.
Yeah.
And you in the suit, it tracks your movements and compares you to that standard. And if you deviate, it can haptically correct your.
Right.
And so you have like a visual and muscular memory combined, so it increases the performance massively. That's exactly the same thing for this, but this one got extra technology called force feedback. So effectively it stops your fingers at a certain point so you could feel the volume of the objects in virtual reality. Because like the virtual reality issue is the problem is that all the objects are pictures.
Yep.
They're not real. It's a thin air. And when you try to interact with those objects with the controllers, that's fine. But with anything else, your hands would just go through them.
Yeah.
So we effectively created a glove that allows people to freely move their fingers, but also interact and touch the objects.
So this is John. John is going to control my hand.
Yeah. No. Just keep it. Yeah, just keep it steady. 1 second. We try to restrict your arm, so if you like try to move a little bit, like maybe you can't because you're restricted.
Yeah, there's definitely tension there.
So can you try to move your different fingers?
Yep, that's definitely weird.
So we effectively have a case where we just wanted to show how you can control one hand with another.
Yeah.
So for training, for medical purposes as well, for rehab, so you can do one hand help another.
And I suppose constantly repeating it as well, you get the muscle memory thing kicking in eventually, yeah. And
Does it feel weird? You want to
It does. Like each time my finger moves, I feel like I want to go, oh, what's that, and grab it, but I can't because there's no control to it.
So idea is, if you can imagine, so let's say if you're grabbing an object like my hand in VR, you feel the volume of that object.
So like if I'm like picking up a glass or something,
that's right.
I've got that.
You feel that resistance for the volume of that object.
Yeah.
But effectively you're touching space. Like,
Yeah.
you know.
So just like shake Sergey's hand for me. Yeah.
So
Utterly
obviously
bizarre.
you need to have a mental.
Yeah, when you've got the
VR
headset and stuff on as
then
well.
your mind is properly trained.
Yeah.
Yeah.
It's fantastic.
So
And there's, like you say, there's so many applications for that.
let me
What sort of like remote range could you have on this? So like, could someone be at a say a hospital in London teaching someone in Birmingham?
That's exactly the case. Like, yeah. So this is in gaming, in training. So we created a suit for enterprise training, and then we realized obviously it's mostly applicable for like military, police, firefighter. They need the full body, they need full immersion. Where employees like learning how to build the motors at Rolls-Royce, they just need the hands and VR.
Yeah.
And all the companies moving into sort of big companies moving into VR training. And we have a perfect tool for that.
It's fantastic. Thank you so much.
Pleasure.